Hello everyone, in this video we cover the numericals based on the base theorem. So let's start to solve one by one. So this is the first basic question. So let's see what is this. So in 2025 there will be 3 candidates for the post. The Professor XYZ, whose chances of getting the promotion is 4:2:3 respectively. The probability of X, if selected, introduce new subject is 0.35. The probability of Y and Z doing the same are the probability 0.52 and 0.80. What is the probability then a new subject is introduced in the department in 2025? So let's see how this solve. So first information we get from the question is the probabilities. So these are the probability of X, Y and Z. So 4:2:3. So this is the ratio, and if we add this ratio 4 plus 2 plus 3, then we get 9. And if we now try to find out the probabilities based on this term, then the probability of X is 9 out of 4. This 9, and this is the data of X, Y and Z respectively. So the ratio of X is 4, so 4:9. The probability of Y, so probability of getting Y is selected is 2 in the ratio, and in probability we write 2:5, 2:9. The probability of getting Z selected is 3, so 3:9. The probability of the respective person with the total ratio, so that's why we're doing this. Now next, the probabilities which are given here for the subject which is introduced new if the X is selected, Y is selected and Z is selected. So for that we write the probability of getting a new subject is selected with respect to X is 0.35. Sorry. The probability of introduce new subject with respect to Y is 0.52, which is mentioned here. And with respect to Z, the probability of selecting the new subject with respect to Z, new subject with respect to Z is 0.80. Now we want to find out the probability of a new subject get introduced. So we not find out the probability with respect to any person. We want to find out overall probability of the new subject get introduced. So how we find out this? So probability of selecting new subject. So for this we have 3%, and with respect the probability, and with respect the new subject get selected. So one by one we parallelly put all the data. So how we put it, let's see here. So probability of X into probability of X with respect to new subject introduced with respect to X, so n by X, plus probability of Y into probability of n by Y, new subject introduced with respect to Y, plus probability of Z into probability of new n divided by Z. And now just put all the values. And in this same manner, if any question is asking just changing the data, then the logic is same. What entity you must find out, see that entity, and with respect to that entity, each probability which is mentioned in the question, just put it parallelly. X x plus y y plus z z. What we do here? Same things. So just see the entities which are matching to each other and just multiply them, add them, multiply them, add them. So the value of probability of x is 4 by 9 into 0.35 plus 2 by 9 into 0.52 plus 3 by 9 into 0.80, and when you calculate these entities you get 0.54. So I hope you get the idea about this question. This is the simple basic question where only you want to find out the overall probability. Now we see the next question. So now the next question is simple. There are 3 boxes, 1 white, 2 red and 3 black in one first box, 2 white, 3 red and 1 black in second box, and 3 white, 1 red and 2 black in third block. A box is chosen random and the 2 balls are selected random. The 2 balls are the 1 red and 1 white. Find the probability that these come from the first box. So first we see what we want to find out. So the probability of selecting the first box where we get the red, 1 red and 1 white ball is given. So I hope you know the Bayes theorem. If not, then just I show you what is the formula. So here we want to find out this entity. First I show you what is the Bayes theorem. So Bayes theorem is nothing but the probability of getting A given B is equal to probability of A into probability of B given A divided by probability of B. Now how you remember this formula? So simple. First, what is given here? A. We want to find out A with respect to B, where B is given. So A given B. So here A is present first. So right here probability of A. Change the terms. Here A is first. Here now B is first. So now B given A, and in upon the first A we use here, then here write B, which is the second term. In this way I remember the formula. So I hope you also remember this formula. If not, then use my trick. First write first entity as it is, second time shuffle the terms, and in denominator second term write as it is, and this is the Bayes theorem. Now same here, we want to find out the probability of first box where 1 red ball and 1 white ball is given. Now how we find out this? Let's see one by one. So first we find out the probability from selecting only the boxes, not the balls from each boxes. First we find out the probability of each selecting one box out of 3. So probability of selecting the first box, probability of selecting first box is 1 by 3. From 3 boxes we select only one, first box. Probability of selecting second box, so out of 3 we select 1. Probability of third box is nothing but 1 by 3. Out of 3 we select 1. So this is the probabilities only for selecting the boxes. Now we find out the probabilities with respect to balls. So first we find out the probability of red and white with respect to first box. Why we write this? We want to find out the probability of red and white balls with respect to first box. Here the term which is given right after the dash and before which term we want to find out. So here we want to find out the probability of red and white ball. So this is nothing but now simply don't concentrate on this term, only simple we want to find out the one red and one white ball from the first box. So from now how many white balls present in the first box? One white box. So from 1C1 the combination formula, 1 out of 1 we select into red balls, two red balls are present, so 2 out of 1 we select. And how many balls are total are present in the first box? 1 plus 2 3, 3 plus 3 6. So out of 6 we find out 2. I hope you get what is the meaning of this formula. This is for the white box, this is for the red box, and this is for the total. So as we know, the probability is nothing but the favorable outcome upon total outcome, means the selected entity upon total entity. So we want to select red and blue out of total balls. So if you solve this, then NCR is nothing but n factorial upon n minus r factorial into r factorial. So same formula if we apply for these entities. So 1C1 is nothing but n factorial. Now n is 1, so 1 factorial divided by 1 minus 1 factorial into 1 factorial. So here this 1 factorial is 1, here 1 minus 1 0 factorial, and this 1. Now 0 factorial is nothing but the 1. So 1 divided by 1 into 1 is equal to 1. 0 factorial always 1. So in this way we find out 2C1, same 2 factorial upon 2 minus 1 factorial into 1 factorial, which is come 2 divided by 1 means 1, and 2 factorial C6C2, which is 6 factorial upon 6 minus 2 4 factorial into 2 factorial. If you do the calculation, means 6 into 5 into 4 factorial divided by 4 factorial into 2 into 1. This 2 factorial expand here, 4 factorial cancel, 2 ones are 2, 2 threes are 6, 3 into 5 15. So now if we put these terms one by one here, then 1 into this is nothing but 2 divided by 15, so we get 2 by 15 for this first term. PRW given to first. Now in this way we find out one by one all the boxes. So now second, PRW means one red ball and one white ball from second box. We here we want to find out the probability for the balls, so that's why we write here, and from whom? Second box. So same. Now see, in the second box 2 white balls and 3 red balls, and we find put one box a ball respectively. So 2C1 for the white into red, 3C1 divided by 6C2, because total 6 balls are the present. 2 plus 3 5 1 6. So same function, means same formula, n factorial upon n minus r factorial. If not you remember, then quickly I give all these steps one by one. So 2 factorial upon 2 minus 1 factorial into 1 factorial, which is nothing but 2 into 1 divided by 1 into 1 is equal to 2. Then 3C1. 3c1 3 factorial upon 3 minus 1 factorial into 1 factorial. The formula for this I hope you know. Here I write, means you compare one by one. NCR is nothing but n factorial upon n minus r factorial into r factorial. Same things happening here. So this n means 3 factorial, n minus r means 3 minus 1 factorial into 1 factorial means r factorial. So this 3 into 2 factorial, here 3 minus 1 is 2, 2 factorial into 1, 2 get cancelled. So here 3 is come. Now again, next 6c2, which we find out here in first question itself, so no need to find out again and again, which is 15. So directly we put the values. So here we get this 15, for this 2 into for this 3, so we get 6 by 15. This is the second term. Now third one, same, we find out probability for a red and white ball with respect to third box. Now same, we see the balls which are present in third box. So 3 white balls and 1 red ball is present in third box. So 3c1 into 1c1 divided by total 6 balls are present, and we find out 2. Here total 6, we put it 3 out of 1, 1 out of 1, and total 6. 3 plus 1, 4 plus 2, 6. Now same 3c1, which we find out here, no need to find out again and again. 1c1, which we find out here. 1c1, where here 1c1, and 6c2 here 15. So only we put all the values one by one. So this is nothing but 3 into 1 divided by 15, 3 by 15. So this is the third term. Now just we find out what we want to find out, the probability. Main question is find out probability for selecting first box with respect to R and W is given, means red ball and white ball is given. Find the probability that this comes from first box. So given is the first box. We find out the probability for the first box, and red and white balls are the given. So probability of first, we find out RW. So this is nothing but, as I give you trick, first write the first term, probability of first. So probability of first. Now interchange the position into probability of RW and first. First term write as it is, interchange the positions, and now second term write as it is, probability of RW. This is the base theorem, which is I mention here. This first term interchange and second term. Now this entity we know, probability of first, we write here. Probability of first we know, where we find out here. Probability of first 1 by 3, put it 1 by 3 into probability of RW with respect to 1 is 1. So this is also we find out, where we find out here, RW with respect to first. So it is nothing but 2 by 15. 2 by 15. But the probability of RW is we find out, see here, this is no, this is no, 1, 2, 3, and these 3 terms we find out, where probability of RW we find out no. So for this also one trick which I remember, I also share with you. So if we find out the probability of RW, so probably here this is term for the probability of RW. This is our original rule. So the trick for find out the probability of RW is, we want to find out probability of RW. So if you see this probability of RW, then we find out one terms here. Probability of RW with respect to 3. Probability of RW with respect to 2. Probability of RW with respect to 1. So RW always come in denominator. Probability of RW with respect to first. Probability of RW with respect to second. And probability of RW with respect to 3. Now, whom respect to RW? First. So write probability of first plus probability of second plus probability of third. RW, we want to find out probability of RW, then this is always come at the denominator, and with respect to each entity we write one by one, and we find out this term also here. So we write this RW first, RW second, RW third, and into probability of first, probability of second, probability of third. And what we do in first numerical itself, same things. If you observe carefully, then we want to find out probability of n. So n is present at each numerator n, and with respect to x, y, z, and we only multiply each probability with respect to that n, y, x. So like this I remember the formula, you also try, it is simple. Now here we want to find out RW, so all the terms related RW write as it is and multiply each term one by one, and just put it now each value. We have RW with respect to I, probability of RW with respect to I means first is 2 by 15. Put it 2 by 15 into probability of first 1 by 3 plus RW second 6 by 15 into probability of second, this is same 1 by 3 plus probability of second third 3 by 15 into 1 by 3. Now just calculate the terms, you get it. So this 15 into 3 45. So 2 into 45 plus 6 into 45, 15 3s are 45 plus 3 by 45. So which is nothing but 2 plus 6, 8 plus 3, 11 by 45. Now just put it here in this formula. So again this is 2 by 15 3s are 45 divided by this 11 by 45. This okay, I simplify for you. So now this is present at the denominator. When you move this in the numerator, then this is 2 by 45 into 45 by 11. This numerator change with denominator. So this term now 45 get cancelled, 2 by 11. So the final answer is for the probability of first given RW is equal to 2 by 11. In the same way, if the question is like find out the probability with respect to second box, choosing the second box and red ball or white ball in question is changed, then the same way you find out, you get the answer. Now still if any question or query, then let me know in the comment box. Thank you.